What if the next great leap in energy doesn't emerge from Silicon Valley but from the heart of Africa? What if the most disruptive breakthrough in power storage is taking shape where sun, wind, and ingenuity collide in ways the world has overlooked? What if the future of reliable energy is being prototyped right now in places most maps barely highlight? Stay with me, because what I'm about to reveal doesn't just tweak how we store power. It challenges everything we assume about batteries, grids, and who gets to lead the energy transition. Forget the battery playbook you've memorized over the past decade. A quiet revolution is moving from lab benches to dusty workshops, from remote villages to bustling ports, and it's accelerating. This isn't a marginal upgrade with a new electrolyte or a better cathode. It is a fundamental shift that reframes energy storage as something simpler, safer, and far more democratic. And yes, global energy giants are already paying attention. Our lives run on batteries we barely see, yet the cracks are showing. We've optimized lithium-ion to astonishing heights, but the model is straining under scale, cost, heat, and risk. Today, I want to show you a path that makes power abundant, affordable, and reachable for everyone. It's not a dream, and it's not a distant promise. It's a technology born from Africa's materials, Africa's climate, and Africa's problem-solving culture. Let's start with where we are and why the status quo is failing us. Global electricity demand keeps climbing as billions connect, electrify, and digitize their lives. We're adding renewables faster than ever, yet the sun still sets and the wind still pauses. That mismatch between generation and demand is the heart of our storage problem. Batteries are the bridge, but the bridge is buckling under weight and cost. Lithium-ion gave us smartphones, laptops, and the EV revolution. It is an engineering marvel, compact and powerful, but it was never built to shoulder every job. For grid-scale storage, costs are dropping slower than hoped, and raw materials are biting back. Lithium is abundant, but not easily accessible where we need it at the price we want. Cobalt has been an ethical and supply headache for years and still isn't fully resolved. Nickel prices swing wildly, supply chains stretch across oceans, and geopolitics can freeze projects overnight. Even when materials are steady, manufacturing footprints are large and energy-intensive. Cycling performance degrades with heat, and many hot regions need storage most precisely where batteries struggle. Fire risk, while manageable, remains a real concern for utilities and communities near large installations. And recycling, although improving, is still a complex, costly, and uneven patchwork. Now factor in the resources required to electrify everything, everywhere. We need longer duration storage to back up the grid for hours or days. We need rugged systems that thrive in heat, dust, and humidity. We need designs that use common materials, not constrained metals. We need storage that lasts decades, not just years, without losing its punch. Lithium-ion is brilliant for mobility and short-duration smoothing. But asking it to carry long-duration, high-temperature, low-cost grid duty is asking too much. Flow batteries promise flexibility, but wrestle with membrane costs and material availability. Hydrogen is exciting for industry, but suffers round-trip efficiency penalties and infrastructure complexity. Pumped hydro is cheap, but needs mountains, water, and permits that can take a lifetime. Meanwhile, the planet keeps heating, and communities are paying the price. Heat waves stretch grids to breaking and push air conditioners into overdrive. Storms intensify, knocking lines down and cutting power when people need it most. Data centers, hospitals, and cold chains can't blink, not even for minutes. Every gap in our storage arsenal is a gap in human resilience. Let's talk about the hidden costs we rarely see in the battery supply chain. Mining uses land and water in fragile ecosystems. Communities near extraction sites often bear environmental burdens without sharing in the gains. Transporting raw materials across continents adds cost and emissions, and every delay trickles down to the people waiting for reliable, affordable energy. All of this sets the stage for a disruptive answer we've needed for years. A storage solution that doesn't rely on scarce metals, one that loves heat rather than fears it, one that can be built from materials you can find in a quarry, a kiln, or a field, one that turns Africa's natural advantages into a global engine for resilience. Enter the African battery killer that is not really a battery at all. Imagine a modular thermal energy cell that stores heat instead of chemical charge. Imagine it made from basalt rock, carbon foam, and sand sealed inside insulated blocks. Imagine charging it with sunlight and wind by simply heating it up. Imagine pulling power back out through a solid-state converter with no spinning turbines. This is the baobab cell, a thermal storage module inspired by the tree that thrives in extreme climates. It's a stackable, container-sized system built from abundant, low-cost materials. It doesn't burn, it doesn't explode, and it shrugs at the hottest days of the year. It's not only storage for electricity, it also delivers industrial-grade heat for factories, farms, and desalination. Here is how it works, step by step, without magic. When the sun shines or the wind blows, electricity flows to the baobab cell. That power heats dense carbon blocks and basalt aggregates inside a sealed, insulated chamber. The chamber climbs to extreme temperatures, locking energy into a thermal reservoir. The hotter the reservoir, the more energy stored per unit of material. Insulation keeps the heat in for days or even weeks, depending on design. When you want electricity back, the hot reservoir emits light like a miniature sun. Special thermophotovoltaic tiles convert that tailored light into electricity on demand. They are like solar panels tuned for a glowing heat source instead of the sky. Spectral filters and emitters ensure only the right wavelengths hit the tiles. The result is a solid-state heat-to-power machine with no moving parts in the conversion stage. No bearings to fail, no fluids to leak, and minimal maintenance. The rest of the stored heat can be piped as clean process heat for industry. Bakers, brewers, textile mills, and hospitals can tap that heat directly. Cold storage systems can run absorption chillers using the same thermal reservoir. Because the core materials are stone and carbon, the cost of energy capacity is tiny. You're not paying for exotic metals per kilowatt-hour of storage. You're paying for rock, insulation, steel casing, and a clever way to harvest light. Electricity out isn't as efficient as chemistry for every use case. But the system shines when you value both heat and power together. In sunny, hot regions, this geometry is a perfect fit. The baobab cell thrives in environments that punish conventional batteries. Heat boosts its efficiency, and the sun fuels its charge for free. Dust can be mitigated with simple filters and sealed enclosures. And because it's modular, you can deploy one unit or build a field of them. If you're picturing exotic silicon wafers and complex supply chains, pause. Africa's innovation isn't just the idea, it's the manufacturing pathway. Ceramic photonic components can be made with established kiln techniques. Carbon foams can be derived from agricultural waste like coconut husks or sugarcane bagasse. Basalt and sand are local, plentiful, and easy to process. The airside tiles do need precision, but the team reimagined how to make them. Instead of chasing the rarest semiconductors, they engineered durable, high-temperature ceramics with thin film coatings. Think of it as a robust, repairable tile rather than a fragile chip. If a tile fails, you replace it like a roof shingle, not a whole roof. You keep the mass, the insulation, and the reservoir intact. Now imagine this rolling out in October 2025. A Pan-African coalition unveils a pilot network from Morocco to Kenya to South Africa. Local factories stamp out insulated shells and photonic tiles on repurposed production lines. Universities test performance, train technicians, and spin out startups. Utilities sign power purchase agreements that blend heat and power for industrial customers. Picture the first trials. A tea processing cooperative in Carrico uses a single baobab unit to dry leaves at night. The same unit powers lights, pumps, and a clinic fridge without diesel. In Ghana, a cold chain hub keeps vaccines safe through a storm and a blackout. In Namibia, a desalination plant pairs wind and baobab cells to supply water after dusk. Zoom out and consider the economics that make this a battery killer for stationary storage. Capacity cost is dominated by cheap materials that last decades. Module lifetimes target 20 to 30 years with minimal capacity fade. The heat pathway is near lossless when used directly in industry. Electric round-trip efficiency is lower than the very best electrochemistry, but more than good enough when heat has value. For the grid, long-duration energy often matters more than peak instantaneous efficiency. If you can store days of energy cheaply and dispatch it when needed, you win resilience. If you can do it without fire risk and supply chain fragility, you win confidence. If you can manufacture locally and train local talent, you win economic empowerment. This trio is the core of the baobab advantage. Let's compare apples to apples on what really counts. Safety tilts hard toward thermal storage built from rock and carbon. There's no electrolyte to vent and no runaway reaction to fear. On cost, materials like basalt are measured in dollars per ton, not hundreds per kilogram. On lifetime, ceramic and carbon systems laugh at heat cycles that torture lithium. Where lithium-ion wins is energy density in compact packages. That is essential for phones and cars, not for containers in a field. Where lithium-ion also shines is mature supply chains and proven bankability. That is changing as insurers and investors gain confidence in thermal projects. Every successful pilot pushes the risk premium down and unlocks big finance. Hydrogen offers seasonal storage and industrial feedstock potential. But compressing, transporting, and reconverting it is a heavy lift. Thermal storage sidesteps those steps for many applications. It lives beside the load and feeds it directly with heat or on-demand power. The simpler the chain, the fewer the losses and the lower the operating costs. You might ask, why Africa and why now? Because the ingredients are here and the need is immediate. Basalt, clay, sand, carbon feedstocks, and sunlight are Africa's daily realities. So are heat stress, fragile grids, and diesel dependency that bleeds communities dry. Innovators are forced to design for harsh conditions and tight budgets. That constraint is a crucible for good engineering. It favors robust, repairable, local solutions over delicate imports. It forces systems to be understandable by a technician with a toolkit and a phone. It rewards designs that can be scaled up in a warehouse, not a clean room. It pushes teams to build for decades, not just the next quarter. The baobab story didn't start with a top-down decree. It started in workshops, rural microgrids, and labs that tested cheap materials in extreme heat. Early prototypes were rough, stacking bricks and carbon rods inside repurposed tanks. They melted, cracked, and taught invaluable lessons. Every failure mapped the path to the first stable reservoir that could hold heat for days. A breakthrough came with a new thermal emitter made from ceramic layers. It selectively glowed at wavelengths that the TPV tiles love. Efficiency jumped without resorting to fragile, expensive materials. The bill of materials stayed local, and the assembly steps were teachable. That combination, not a single patent, is the real innovation. The next unlock was sealing and insulation. High-temperature seals based on common industrial fibers cut losses dramatically. Aerogel-like performance was achieved with ash-derived insulation composites. Costs fell while durability rose under brutal cycling. Suddenly, the math made sense for bakeries, mills, and clinics. What does a baobab field look like in practice? Imagine a row of insulated modules behind a factory, each the size of a shipping container. Solar arrays feed them by day and they glow quietly inside after sunset. Heat lines run to ovens or boilers, while cables carry firm power to the plant. A small control room monitors tile temperatures and power conversion in real time. Maintenance is simple and scheduled. Inspect insulation, swap a tile if its output dips, reseal joints annually. There are no fuel deliveries and no spinning machinery to rebuild. Dust filters and passively cooled inverters handle ambient heat. The system stands there like a row of modern kilns, turning sun into dependable work. For rural communities, a single module can transform daily life. It charges from a microgrid or a few wind turbines. At night, it powers lights, pumps water, and runs a refrigeration chain. It also provides cooking heat, eliminating smoky fuel wood in kitchens. Health improves, kids study after dark, and small businesses stretch hours safely. Now consider the global reaction in this imagined October 2025 moment. Legacy utilities see a way to decarbonize process heat without expensive gas retrofits. Industrial firms realize they can hedge fuel volatility with a one-time capital investment. Battery giants notice that grid-scale contracts are suddenly more competitive. Investors smell a category that can scale without exotic inputs. Some incumbents will resist, of course. They'll argue about round-trip electrical efficiency and highlight what thermal cannot do. They're not wrong for specific niches, but they're missing the bigger picture. The world needs a portfolio of storage tools, and thermal fills a giant gap. It complements lithium rather than competing in every arena. Let's walk through concrete examples where Baobab cells change the game. A Kenyan tea processor replaces a steam boiler with Baobab heat and slashes fuel bills. Night drying becomes cheaper and cleaner without waiting for the grid. A Nigerian data center couples Baobab with rooftop solar to flatten diesel use. Backup generators become rare rather than routine. In South Africa, a mining operation uses Baobab cells to power ventilation at night. Grid outages no longer halt operations or endanger miners underground. In Senegal, a fishery runs absorption chillers from Baobab heat. Ice production continues through cloudy days without burning diesel. In Morocco, a ceramic tile factory literally uses stored heat to fire its kilns. Hospitals and clinics benefit immensely. Sterilization cycles, vaccine fridges, and surgical lights demand rock-solid power. Thermal storage improves resilience during storms and heat waves. Generators become last-ditch backups rather than daily lifelines. Healthcare outcomes improve when power becomes a constant, not a gamble. Education centers and universities gain consistent power for labs and digital classrooms. Evening courses run without flickering lights or hot, stuffy rooms. Students study longer and teachers plan with confidence. Communities gather in illuminated spaces that foster safety and entrepreneurship. Small-scale manufacturing flourishes when downtime evaporates. On the farm, Baobab cells power irrigation and cold storage. Harvests are saved rather than spoiled in the heat. Farmers sell more at better prices because quality holds longer. Off-grid villages tie multiple modules into a mini-thermal network. Each module serves a purpose while the whole system backs up the community. The economics are straightforward to grasp. You pay once to build capacity from affordable materials. You harvest free or cheap renewable energy whenever it's available. You dispatch heat and power when it's valuable, not when the wind says so. Your operating costs stay low because maintenance is simple and predictable. Lenders like assets that are durable and salvageable. A Baobab module is a chunk of engineered material with resale value. It is not a consumable that fades to scrap after a few years. Insurance underwriters like systems that don't burn. Communities like systems they can understand, repair, and eventually own. Skeptics ask about efficiency, and we should answer honestly. Converting heat back to electricity isn't 90% efficient, but the total system value is higher when you count both heat and power. In regions where heat drives industry, this is a perfect fit, and the design keeps improving as photonic tiles get smarter and cheaper. Others ask about storage duration. Thermal losses exist, but good insulation buys days of effective storage. For many applications, that's exactly the gap we need to fill. Seasonal storage remains better suited to other techniques, but for daily and weekly stability, baobab cells excel. Materials durability is another fair question. High temperatures stress seals, coatings, and casings over time. That's why the African teams prioritized modularity and easy replacement. Parts are standardized and swapped on schedule like brake pads. You don't rebuild the engine, you maintain the parts that wear. Training is critical for scale, and the plan reflects that. Technical colleges add thermal storage modules to curricula. Manufacturers host apprenticeships and certify installers. Community energy cooperatives train operators and dispatchers. The knowledge stays where the systems live. Policy will shape the speed of adoption. Tariffs should reward clean, dispatchable heat and power. Grid codes must recognize thermal storage as a firm resource. Procurement rules should value resilience, not just sticker price. Local content policies can anchor jobs and build regional supply chains. The geopolitical implications are profound. When storage decouples from rare metals, power shifts geographically. Africa's deserts and coasts become engines of clean energy security. Trade flows move from shipping chemicals to shipping know-how. Instead of exporting only minerals, Africa exports technology and finished systems. This reframes the narrative around the energy transition. It is not charity, and it is not dependency. It is leadership forged in necessity and delivered with elegance. It is a blueprint for building resilient infrastructure fast, at scale, and with local pride. It is a way to align climate goals with real development wins. For people at home, what changes is everything you feel day to day. Fewer blackouts, quieter nights, cheaper bills, and cleaner air. Clinics that never lose refrigeration and water pumps that never stall. Fiber internet that stays up because the nodes have firm power. Bus depots that charge fleets after dark without spiking the grid. For factories, it means predictable energy budgets year after year. No more chasing diesel prices or hedging LNG contracts. No more unexpected production halts when the grid hiccups. Improved product quality when heat processes are steady and clean. Lower emissions that open doors to green export markets. For entrepreneurs, it's a wave you can ride. From insulation fabrication to photonic tile assembly, opportunities abound. From installation services to monitoring software, value stacks along the chain. From community ownership models to industrial service contracts, finance follows. When energy gets reliable, everything else gets easier. For policymakers, it's a strategic lever hiding in plain sight. Set clear standards for safety, performance, and recyclability. Fund pilot corridors that build local expertise quickly. Tie procurement to workforce development and small business participation. Measure success in uptime, jobs, and health outcomes, not just megawatts. For global partners, it's an invitation to collaborate respectfully, co-develop technology without extracting the crown jewels, license fairly, build capacity locally, and share risk and reward. Recognize that leadership can come from Nairobi, Accra, Kigali, and Rabat. This is what a balanced energy future looks like. Critics will say the world doesn't change this fast. They are right that scaling manufacturing takes time and discipline. But remember how quickly solar and mobile money exploded across Africa. When a solution solves real problems at the right price, adoption can be breathtaking. When communities see it work, they spread it faster than slogans ever could. What about recycling and end of life? Stone, steel, and ceramics are easy to reuse or repurpose. Carbon components can be recovered or reburned in controlled processes. Photonic tiles can be refurbished and slotted into new modules. The system is circular by design because the materials are simple. What about weather extremes? Heat is the friend of thermal storage, not its enemy. Heavy rains and storms are mitigated by sealed, raised housings. Dust is handled with filters and scheduled cleaning. Flood-prone areas can elevate modules on plinths like any critical infrastructure. Financing remains the perennial question. Power purchase agreements can bundle heat and electricity in one contract. Industrial clients can lease modules like they lease equipment. Community cooperatives can own units and sell services locally. Multilateral banks can underwrite early deployments tied to resilience goals. Is this the end of lithium-ion? Absolutely not, and that's great news. Lithium will keep powering vehicles and short-duration smoothing with excellence. Thermal storage takes the night shift, the heat load, and the heavy lifting. Together, they form a portfolio that decarbonizes faster and cheaper. What does adoption look like over the next 5 years? Year 1 proves reliability at dozens of sites with diverse use cases. Year 2 scales manufacturing and trims costs through learning curves. Year 3 wins large industrial contracts and grid partnerships. Year 4 and 5 embed Baobab cells into national energy plans. By then, other regions will adapt the idea to local needs. That is good and expected, because climate solutions spread best when they localize. Africa remains the pioneer and gains from licensing and expertise exports. The world benefits from a broadened storage ecosystem that is harder to disrupt. And everyday people benefit from systems they can trust and afford. The story resonates because it aligns engineering with equity. It finds value in materials the world ignores. It builds resilience where the climate squeeze is tightest. It empowers communities to own critical infrastructure. It challenges the old map of who leads and who follows. If you're watching this and thinking, how can I be part of it? Here's how. If you're an engineer, explore thermal, photonic, and ceramic disciplines. If you're an entrepreneur, look at fabrication, installation, and financing models. If you're a policymaker, draft standards and incentives that unlock pilots. If you're a citizen, ask your leaders to invest in resilient local energy. The technical frontier is still evolving, and that's exciting. Better selective emitters can raise electrical conversion efficiency. Smarter controls can shave losses and extend storage duration. New insulation composites can cut costs and improve performance in humid climates. Design for modularity can keep systems running even during component swaps. Data will tell the tale over time. Capacity factors, maintenance logs, and lifetime performance will prove or disprove the promise. We should demand transparency and independent testing. We should watch how systems perform in heat waves and storms. We should celebrate successes and learn fast from failures. There will be copycats, and that is fine. The true moat is not secrecy, but the ability to build at scale with quality. The teams that train, certify, and support communities will win long-term. The companies that design for repair will earn trust. The coalitions that share benefits fairly will earn loyalty. Imagine the moment when a city switches on a baobab field after sunset. Streetlights glow steadily and factories hum through the night. The air smells cleaner because diesel generators are silent. The hospital runs a sterilization cycle without worrying about grid cuts. Kids finish homework with bright lights and cool fan air. Imagine the moment when a port runs cranes and cold storage from stored sunlight. Ships dock and unload on schedule without burning extra fuel. Refrigeration stays constant and food waste drops sharply. Workers breathe easier and businesses plan ahead with confidence. The economic ripple is immediate and tangible. Imagine a drought year when hydropower falters. Thermal storage fills the gap at night and during peak demand. The grid doesn't collapse under the strain of heat waves. Vulnerable communities don't pay with rolling blackouts and lost livelihoods. That is what resilience looks like when storage is abundant. This is not just an engineering story. It's a cultural story about reframing Africa in the global imagination. Innovation doesn't need a permission slip from established hubs. It needs a problem, resourcefulness, and the courage to try. Africa has all three in overflowing supply. This is also not a zero-sum story. When stored energy gets cheaper and safer, the world wins. When the grid gets steadier, productivity grows everywhere. When communities control their power, democratic resilience grows stronger. When industries cut emissions, we all breathe cleaner air. The takeaway is simple and provocative. The battery era isn't ending, but the battery monopoly is. Storage is plural, and Africa just added a powerhouse to the mix. The baobab cell is a reminder that sometimes the best path is the oldest one. Heat, stone, light, and a dash of human ingenuity. Will every project succeed? No, and we should be honest about that. But the direction is right and the momentum is real. We're converging on a class of solutions that aligns physics with place. That is how revolutions cement themselves into daily life. So, the next time someone tells you energy innovation only happens in glass towers, smile. Tell them about kilns, basalt, and photonic tiles. Tell them about clinics that never go dark and bakeries that never run cold. Tell them about factories that fire their kilns with yesterday's sunlight. Tell them about a continent turning its climate into a comparative advantage. And if you're still asking whether this is hype, watch the pilots. Watch the contracts that bundle heat and power in smart ways. Watch the kilowatt hours that show up after sunset, night after night. Watch the grid reliability metrics tick upward in places that need it most. Watch communities choose systems they can touch, fix, and own. We started with a question, and we can end with one too. What if the world's most important energy story in 2025 doesn't come from where everyone is looking? What if it comes from Africa and radiates outward, reshaping markets and mindsets? What if the era of extracting rare metals gives way to an era of shaping abundant materials? What if the simplest ideas, scaled with care, are the ones that finally win? This is the promise of Africa's battery killer, the baobab cell. It's not the only answer, but it is a powerful one. It is a bet on local materials, local talent, and global impact. It is a challenge to think beyond chemistry and aim for resilience. It is a story still being written, one glowing module at a time. Thanks for watching and for keeping an open mind. If this sparked your curiosity, share it with someone who thinks energy is boring. If you want to see these systems up close, tell us which pilot you want us to visit. Subscribe for deep dives into the tech, the teams, and the communities making it real. Because the future of energy might be closer than you think, and brighter than you've been told.